Hi, I'm Ambrosia Ardenvale-Wood, and today I'll be walking you through my analysis of the US renewable energy consumption, solar, wind, and hydroelectric power, spanning over 50 years of data from the US Energy Information Administration. Before diving in, here is the bottom line. Over 50 years of energy consumption data confirms that US renewables have moved from a niche supplement to an exponential growth engine. Using temporal patterns alone, essentially the calendar, total renewable output can be predicted with 88% accuracy. This isn't just a backward look at history, it's a predictive tool showing that spring peak is intensifying every year as installed capacity expands. What follows is how this data can directly inform capacity planning and storage investment strategy. This analysis is framed around the needs of a US energy investment firm. The core question is whether time-based patterns, so season and year, can accurately predict total renewable energy output. If so, that gives grid operators and investors a reliable, forward-looking tool for long-term planning. The data set comes directly from the US Energy Information Administration and contains over 50 years of monthly energy consumption data. After filtering to the 3 sources of interest and handling some structural quirks in the raw file, like annual summary rows that needed to be removed, the analysis works from 634 clean monthly observations. Solar and wind show zeros in their early years. This was a deliberate conservative choice, as those zeros accurately reflect the period before utility scale infrastructure. They are not missing data. Looking at the full 50-year picture in this renewable energy trends slide, we show 3 very distinct stories. Hydroelectric power has been the backbone of renewable energy for decades, but is now declining, largely due to drought and water management constraints. Wind has grown rapidly and surpassed hydro as the dominant source. And solar, while starting from nearly zero, shows the steepest growth trajectory of all 3. This point, around 2010, you'll see noted on the chart there, is worth noting. So this is the moment where renewable technology costs shot downward and the modern investment landscape began to take shape. Everything after that inflection point is the story that this model is built to help navigate. Seasonal patterns. One of the most compelling findings from the exploratory analysis is how well these 3 sources balance each other seasonally. Hydro peaks in spring, and that's driven by snowmelt, presumably. Solar peaks in the summertime from the maximum daylight, which we would also assume. And wind peaks in winter when atmospheric conditions are strongest. For a portfolio manager, this is significant. A diversified mix across all 3 provides more stable year-round output than any single source alone. They actually balance each other perfectly. Notice also what the data reveals in September and October. Solar is fading and wind has not yet ramped up. So just remember that gap for later, and we'll discuss it regarding the most important investment recommendation. The regression model and results. To formally model these patterns, a linear regression was built using temporal features, so years, season, and months, to predict total renewable consumption. Polynomial and interaction terms were added to account for the exponential growth visible in the exploratory data analysis, which improved model accuracy significantly. Importantly, variables that would only be known after the fact were obviously excluded from the model. The focus is on purely temporal growth factors that any grid operator would have available at planning time. This keeps the model applicable to real forward-looking decisions. The final model achieves an R square of 0.88. On this chart, the closer these points are to the red diagonal line, the more accurate the model. So the alignment is tight across the full range of consumption values. Key coefficient insights. The model's coefficients tell a clear story. June is the strongest single month for total renewable output, which is driven by solar peak. Both winter and summer seasons elevate consumption overall. The spring seasonal growth factor of 0.61 is particularly significant. It confirms that spring's contribution to total renewable output is growing stronger every single year as installed capacity expands. On the other side, September and October carry the largest negative coefficients, representing a predictable and quantifiable trough in total output. Business recommendations. 3 concrete recommendations emerge from this analysis. First, major maintenance should be scheduled in late autumn so that assets are fully operational during the spring and summer peak window, where the model shows returns on installed capacity are accelerating year over year. Second, and this is the most important insight from the entire analysis, the September through October trough is not a generation problem. It is a storage issue. So more wind turbines or solar panels in October are not the answer. Better storage infrastructure for the energy that already generated in July is what is needed here. Investment in battery and pumped hydro solutions, specifically sized to bridge that gap, is where the real opportunity lives. And then finally, with an R-squared of 0.88, this model is accurate enough to serve as a secondary validation tool for annual budgetary forecasting and fuel purchase planning. Conclusion. This chart says it all. 3 sources, each with its own rhythm, combining into a portfolio that is growing dramatically over time. To summarize, the US renewable energy landscape is undergoing a fundamental transformation. Solar and wind are growing exponentially. Seasonal patterns are intensifying as capacity expands. And a diversified portfolio across all 3 sources provides more stable year-round output than any single source could alone. The regression model demonstrates that the temporal patterns alone can predict total renewable consumption with 88% accuracy, giving grid operators and investors a data-driven foundation for long-term planning. The October storage gap is the most actionable near-term opportunity. Thank you for your time.